Good afternoon, guys. I hope you guys are all doing well. I hope you're having a good Saturday. Hope your A-levels are going well. I'm just gonna give a few seconds just to let everybody in. Wow, there is a lot of us today. You guys got an exam or something? Let me just see. Okay, there's a couple more people joining. Okay, wow, there's a lot of us today. Okay, first of all, how is everybody doing? How was paper two, by the way? How did you guys find paper two? I don't know, yeah. Okay, just get a few more people in. Very good. Good stuff. Good stuff. It was better than paper one in my opinion. Yeah, I've actually seen the paper. It was there was a couple of tricky questions, but I think it was all okay. But yeah, okay, there's a couple more people joining. I think it's okay, not too bad. Better than paper one. Paper was okay to the second half. Fair enough. Okay, so just as a quick intro, just before we get started, for anybody that's new that hasn't joined any of the classes before, my name is Daniel. I'm a GCSE and A-level maths tutor, and I run these classes. I've been running these classes for I think the last 2 weeks now for Pure, and then now you've got paper three on Tuesday. So we're gonna do a couple of questions. That differential equation question was good. Nice, nice, nice. Okay, cool, cool. So what we're gonna do is obviously today we're gonna go over mechanics. So what I've done, wow, there's a lot of people today. That is crazy. Okay. So yeah, we're gonna go over mechanics today for an hour. I've got a couple of questions. And yeah, so let's make us start. Let me share my screen. So let's see what we've got here. All right, just give me a second. Whoops. All right. You guys should be able to see my screen in a sec. Okay, cool. So we've got a couple questions today. We're gonna do four. So what I've done is I've tried to pick questions where it's most likely gonna come up, right? So we've got four here. We're gonna start off with this one. Let me just admit more people in. Wow, there's about 65 people. That is incredible. Okay, cool. So yeah, just before I get started though, you guys are going to be able to just drop messages in the chat. I'm going to explain it. Obviously, when I'm explaining it, I'm going to be asking you guys questions. So just be aware of the chat. So if I ask any questions, just put a message in. And what else? If you guys ask questions, there's actually a lot more people than there were last week. If I miss a question out in the chat, remember you guys can discuss with each other as well. Yeah. So there's still more people joining. Okay. All right. Admit all. Okay. Cool. So let's make a start. Your YouTube videos are really good. Thank you so much, guys, as well. Thank you very much for all the feedback I've seen on YouTube as well. I really do appreciate it. And everyone that replied to the email, just let me know that you got the Zoom link. But okay, let's make a start. So this is variable acceleration here. Now, looking at this type of question, guys, what are our thoughts on it? Put a 0 if you're looking at this thinking this is very, very hard, don't know what to do, and put a 10 if this is light work. I can't wait for this to come up on Tuesday. I want you guys to all give me a number between 0 and 10, please. Wow. Okay, I can see 7, 8s, 7s, 8s, 10s, good stuff. Okay, so let's make a start with this one. All right. Now, let's see what we have. So the first one says, at time t seconds where t is greater than or equal to 0, right? Sorry, more people are joining. Sorry, guys. I just need to admit them. But anyways, at time t seconds where t is greater than or equal to 0, a particle p moves on x acceleration a, meters per second squared is given by this here. A is equal to 1 minus 4ti plus 3 minus t squared j. At the instant when t is equal to 0, the velocity of p is 36i. Find the velocity of p when t equals 4. So we've got an expression for the acceleration, right? How do we find the velocity? Can somebody tell me in the chat? How do we find, thank you very much. You guys, there's too many. I'm just going to say thank you to everyone. I can see Alex, Salim, Ahmed. Yeah, thank you very much, everyone. Integrate, right? We've got an acceleration. We need to find out velocity. We need to integrate, yeah? So let's do that. So we've got this here. We've got a is equal to, whoops, oh, sorry, it's doing this glitching thing again. What I'm going to do quickly is I'm just going to shut this because it's just glitching, my OneNote. So let me just stop sharing for a second. I'm going to close this and then get up again. Sorry about that. Let's just do it again. And then if I share screen now, okay, it should be fine. Okay, so let's start again. Let's see what we got. So we got this here. So right, yeah. We've got this as a 1 minus 4ti plus 3 minus t squared j. Yeah, we need to integrate now because we need the velocity vector. So we're going to integrate. So v will equal, now we just integrate with respect to t for each component. So if I integrate that there, 1 will go to t. If I integrate 4t, we'll add 1 to the power divided by 2. This would be 2t squared here. This is I, and then plus, and then now we need to integrate this. 3 goes to 3t, and then this will just go to a third t cubed j. We all happy with that? We all happy with that? Eddie, do we continue? I can see yeses, yeses. Wow. Come on, guys. We just finished pure, we've forgotten plus c. Remember, guys, we've got a constant of integration. I know paper two is done, but remember, you've got to add c if we're integrating, guys. Yeah? Yeah, good stuff, good stuff. So now we've got our plus c. Now remember, they gave us this piece of information here. They told us that at time t equals 0, the velocity of p is 36i. So that tells us then, well, if v is equal to 36i, right? I'm going to place this here. And then if t is equal to 0, well, every single part of the I and j components have t. So if everything is 0 here, then this will just become 0 for I. This will become 0 for j, and then I have plus c. Yeah? So that just tells me then that our constant of integration is just 36i. Yeah? So we now know what c is. Now we have a complete equation for our velocity. Now we can figure out what the velocity is when t is equal to 4. Yeah? So more people are just joining, so I'm just letting them in. Okay. Wow, wow, wow. There's nearly 100 people here. Sorry, guys. Okay, yeah, okay. I think that should be okay now. So now we've got our constant of integration. Let's just write out again. We've got a t minus 2t squared I plus 3t minus a third t cubed plus our constant of integration, 36i. Yeah? And what I like to do when I'm doing these types of questions, I like to combine the i's and j's together. So 36i is an I component. So what I'm going to do is I'm going to just bring this together here. So I'm going to write this like this, t minus 2t squared plus 36, right? Or I plus 3t minus a third t cubed. Yeah? J. We forgot the j here as well. Anyways, now what does the question say? We need to find the velocity. We need to find the velocity of p when t is equal to 4. So all we're going to do now is we're just going to plug in t equals 4 into this and see what it gives us. Yeah? So let me get my calculator out and see what it gives us. Whoops, where is my calculator, by the way? Okay, I need to get it. 1 second, guys. Let me just get my calculator so you guys can see it. Okay. Okay, so if I get my calculator out, so yeah, we're just going to plug in t equals 4. So let's plug it into the i's. So this will just be 4 minus 2 lots of 4 squared plus 36. This will give us 8 for the I component. So 8i, and then plus, and then we're going to do the j component here. So we're going to just do 3 times 8. 3 lots of 8, 3 lots of 8, close bracket, and then minus a third 8 cubed. Minus a third, and then, whoops, need a third there. And then times by 8 cubed. Sorry, not 8, sorry, why am I saying 8? That should be a 4, sorry. That should be a 4, because t was equal to 4, wasn't it? 4 cubed. That gives us minus 28 over 3, yeah? So that way, the j component is minus 28 over 3, yeah? Minus 28 divided by 3j. So that is our answer, yeah? Thank you very much, Angie. Apologies for that. So because I'm explaining, sometimes I can just think of a different number. Apologies. But yeah, this is our final answer for that. V equals 8i minus 20 over 3j. And then for part B, let's read it. It says, find the value of t at the instant when p is moving in a direction perpendicular to I. How do we feel about this type of question? This question comes up quite a lot. Moving in a direction perpendicular to I. What do we do here? Exactly. If it's exactly, well done. Yeah. If it's perpendicular to I, well, I is the horizontal component, right? Well, if it's perpendicular, it must be traveling in the j component. Yeah, it must be traveling vertically, completely vertical. There's no horizontal component. That tells us, right, that our I component of velocity must be 0. So what you're going to do is you're going to get your I component of velocity, make it equal to 0. So we can see this one is our I component of velocity here, right? We're going to just make this equal to 0 and then solve, aren't we? Yeah. So what I'm going to do here is I'm just going to put this here. So we're going to get t minus 2t squared plus 36 is equal to 0. And then now you can just put this, you can just plug this. Let me just tidy this up. So minus 2t squared plus t, minus 2t squared plus t plus 36 is equal to 0, right? So therefore, let me get my calculator because we can just punch this into the calculator, can't we? Yeah, put this in. So be menu, then it will be this here, polynomial degree 2. And then what are our coefficients? A is minus 2, t is 1, this one is 1, and then this is 36 here. Got this here. So we get t is equal to 9 over 2. And then there's another one probably, minus 4. Yeah. Now, obviously, we choose t equals 9 over 2 because we're dealing with time. T is greater than or equal to 0, as they've said it here. Yeah. So we have to pick the 9 over 2 or 4.5. Yeah. So that's what they were asking for, isn't it? Find the value of t. Yeah, fine. So that's 3 marks done. Okay. Now, double I says, let me just write this here. This is for 6 marks. Place this here. It says at time t seconds when t is greater than or equal to 0, a particle q moves so that its position vector r meters relative to a fixed origin O is given by this here. R is equal to t squared minus ti plus 3tj. We need to find the value of t at the instant when the speed of q is 5 meters per second. So what do we do here? Oh yeah, just a quick one as well. Just a quick one as well. I've just got an answer. Yeah, we'll differentiate. I'm just going to go back to this. We're going to do it in a second. I've just got an answer. What would you do if it was parallel? So that's actually something I actually forgot that I was going to say. So if these ones here, right? Find the value of t when it was moving here. So there's a couple of things that they can ask you in an exam of this type of question, right? They could say moving in the direction perpendicular to I. They can say perpendicular to J. Another thing they can say as well is if it's moving, right? Northeast. So let's say I have a velocity vector. Let's say xi here plus yj. If it's moving northeast, can somebody tell me what we would do here? Exactly. I is equal to j. Exactly. Yeah, because if you think about it like this, if you have a right angled triangle, let's just say this is your velocity, like this here. That is not a right angled triangle. Sorry about that. Just a quick one. Like this here. Well, if it's moving northeast, that's directly 45 degrees. It's halfway between 0 and 90. Well, if it's a right angled triangle, this is 92. Yeah. So we have an isosceles triangle here, meaning that these are the same. Yeah. So that's why if it said moving in northeast direction, you would equate the two components together. Yeah. In this case, it will just be x is equal to y, isn't it? Yeah. Or I equals j, same thing. Yeah. Does that make sense, guys? Yeah. How about if it said southeast? How about if it said southeast, guys? What would we do there? Let me get a graph here. This is northeast here, southeast, right here. What would we do there? Exactly. As we can see here, just a quick one. Southeast is this way. Well, this is the positive I component, and then this is just a negative j component, isn't it? Negative j. So just be I is equal to negative j. So just be aware of that for the exam. They can ask you a couple of different ways to do these types of questions. Yeah. And if it was moving parallel to, for example, I can see parallel in the chat. If it says it was moving parallel to any component, then that would mean there would be no of the other. So for example, if it said it was moving parallel to the I component, then there would be no vertical component. There would be no J component. Does that make sense? If it was moving parallel to I, it would be traveling horizontally. So there would be no vertical component. So you'd make your vertical component 0. Does that make sense? Yeah, and then vice versa. Yeah, good stuff. All right. So yeah, let's continue. Got this here. We got this one. Now, let's see. So it says double I at time t seconds, where t is greater than or equal to 0, a particle q moves so that its position vector r is blah blah blah. Now we need to find the value of t at the instant when the speed of q is 5. So remember, this is our position vector here. We know what we need to do. We just need to differentiate this, don't we, to get an expression for the velocity. Yeah. So we're going to differentiate this here. If I differentiate this, hold on, I've got different colors. Let me just make this all here. If I differentiate this, this will give me v, right? Now this will give me 2t minus 1 I And then plus, if I differentiate 3t, that'll just take me to 3j. So this is an expression for the velocity. Yeah. Now we need to find the value of t when the speed of q is 5. What does that mean? Because this is velocity. They say speed. Exactly. We have to take the magnitude. Remember, speed is a scalar quantity, right? Velocity is a vector. So we need to take the magnitude of v to then get an expression for 5 and then make it equal to each other. Yeah. So we're going to say, well, the magnitude of v, right, is going to be equal to the speed. And this will just be equal to this here. We're just going to do 2t minus 1, right, squared plus 3 squared, right? And this is equal to 5, apparently. Yeah. So now we've got an equation in terms of t that we can solve quite quickly and easily. So doing this here, well, if I square both sides, the square root will disappear. And I'll have 2t minus 1 all squared plus 9 is equal to 5 squared, yeah, which is 25. And then now we can expand this now. This just becomes a 4t squared. That goes squared. 2t times minus 1 is minus 2t. I'm going to double that to give me minus 4t here. Minus 1 squared is a plus 1. Plus 9 is equal to 25. So that shouldn't be there. That should be a 25. Yeah. Okay. So now we've got this now. This is just a quadratic that we're just going to solve. So we're going to do 4t squared minus 40 here. And then this is 10. This is 10. If I take the 25 away, this will just give me minus 15, wouldn't it? Equals 0. Yeah. Just double check the chat. Okay. Okay, yeah, I can see a couple of questions, guys. So if you feel free to just reply to anybody if I can't see it, because there's quite a lot of you. So it just you send a message and then 10 people send a message after, so I may have missed it. But please just reply to people as well. Yeah, and I'll try my best to answer. So we got this here. Now we need to find the value of t where this occurs. So we're just gonna put this into our calculator again, aren't we? Yeah. So put this in. So how do I go back to? Okay, go here. And then polynomial again. So it's going to be 2 here, and it's going to be 4, and then minus 4, and then minus 15, isn't it? This is equal to, t is equal to 2.55 over 2. Yeah? That's the another value for t, minus 3 over 2, minus 1.5. Obviously, again, t is positive, so it has to be t equals 2.5 for our answer, and that's what they were asking us for, isn't it? Find the value of t. Exactly. That all clear, guys? Anybody have any questions on that? Okay. Sorry, could somebody summarize what Dan said for part B moving northeast? So I'll just do that very quickly because I've just seen that message, right? So what I was saying is that for part B, they can ask you a couple of different things, right? So if it's moving northeast, they could say your velocity or your component or your particle is moving in the direction which is northeast, right? If it's moving northeast, that is exactly halfway between 90 degrees and 0 degrees. Yeah. So it would be a 45-degree angle like this, right? Now, if this is a right angle triangle, right, then this is also 45. This is an isosceles triangle. So therefore, these components must be the same. Yeah. So if it says moving northeast, you just equate the I and J components together. But what I'll do is I'm going to summarize this. I'm going to send a OneNote with all of this so you'll be able to figure it out and see it for yourselves as well. Yeah. But cool. That question's all done now. Now we're going to go into connected particles. Yeah. So we got this one here. Now, looking at this one, a question like this. Inclined plane, pulleys, 2 particles together, coefficient of friction, rough, blah, blah, blah. How are we all finding this question here? Put a 0 if you're thinking, listen, don't know what to do here. Put a 10 if this is super easy, light work. I know I'm going to get 100% if this comes up. Just give me an A star already. 7 minus 594. Come on, guys. Come on, guys. Trust me, this question is quite good. Yeah, these type of you guys are killing me in the chat. Okay, cool. Let's have let's have a look. Let's have a look at this one. So let's read it. It says a small stone A of mass 3m is attached to one end of a string. A small stone B of mass m is attached to the other end of the string. Initially, A is held at rest on a fixed rough plane. Straight away, always get the keywords. Rough means that there's friction. Yeah. The plane is inclined to the horizontal at an angle alpha. Tan alpha is equal to 3/4. The string passes over a pulley P that is fixed at the top of the plane. the part of the string from A to P is parallel to a line of greatest slope of the plane. Stone B hangs freely below P as shown in figure 1. The coefficient of friction between A and the plane is 1/6. Stone A is released from rest and begins to move down the plane. Stones are modeled as particles. Pulley is modeled as being small and smooth. String is modeled as being light and extensible. Now, for part A, 2 marks using the model. Using the model for the motion of the system before B reaches the pulley, we need to write an equation down for the motion of A. All right, so what we're going to do here, guys, this question is always easy. Yeah. So, got this here. This is our figure 1. I'm going to put this here. Now, what is the first thing that you should always do when you're dealing with these types of questions, guys? Exactly. We need to draw a force diagram. We need to label. Thank you very much, Yaka, Dom, Anshi, Amrita. Good stuff. Exactly. So let's label our diagram here. All right. So what do we have? Well, remember, let's start with the particle A, right? Remember, this is on an inclined plane. So we're going to have a reaction force which acts perpendicular to the plane, like this here. And we're going to have the weight of the object going down like this. This will be vertically downwards, and this will be the mass times the acceleration due to gravity. This is going to be 3 mg for sure. And what else do we have? Well, what else did they say as well? It says B reaches the pulley. Yeah, that means A is going down the plane, right? So what I do as well is I'm going to do my accelerations like this. This is going down, right? And then this is going up. Yeah, like this. And then obviously we're going to have mg going down like this here. And then the tension is going to be here. Tension is going to be here, like this. Yeah. Is this all okay, guys? Happy with this? Yes or no? I can see lots of yeses. I can see lots of yeses, right? The surface is rough. Thank you very much, guys. There's friction. Yeah. So remember, if it's going down the plane, then we're going to have, what I'll do is I'll do it in another color like this here. Do it like this. This is going to be F, like this. Yeah, I'll just call this F. This is the friction. Remember, friction opposes motion. If A is going down the plane, then friction will act in the opposite direction. Now, another thing that you can do now as well is that we've got all of our forces. Now, remember, we need to resolve. We've got this force here, the weight. We can break this down into components, can't we? Yeah, always do that as well. So let me just get this here. Get this like this here. Get this like this here. This here. This is the angle alpha. Can somebody tell me, please, what this one is? What component this is, please? Exactly. Thank you very much. 3 mg cos alpha. Thank you very much, guys. Fantastic. Yeah. 3 mg cos alpha. 3 mg cos alpha. And then obviously this one is just going to be 3 mg sine alpha, isn't it? Yeah. So this looks all fine to me. I think we've got everything so far. Now for part A, what did part A say? Part A said, write down an equation of motion for A. Yeah. Well, this is just F equals ma, isn't it? Yeah. So what I always do when I'm doing these type of questions, obviously, I'm not sure if you're allowed highlighters in the exam, but when I'm teaching it, I always highlight the forces that I need, right? So I'm looking for the equation of motion for A. Yeah. So I'm going to write for A here. Well, what do we have? Well, it's going downwards. We've got this force parallel to the plane acting in that direction. Yeah. And then what else do I have? What I do, I'm going to highlight every single thing, every single force acting parallel to the plane. So I've got that one going down the plane. And then I've got this frictional force, which is going to be opposing it because it's rough. And then we've got this tension as well. Yeah. So my resultant force, remember F equals ma. Yeah. F equals ma. What I like to think of it as, this is the resultant force. Yeah, is equal to the mass times the acceleration. Now the resultant force, as we can see, well, what's going down the plane? It's the 3 mg sine alpha. Yeah, minus the friction and the tension. Minus F minus T is equal to the mass of the object. The mass was 3m times the acceleration. Does that make sense, guys? Yeah. Oh yeah, also as well. Thank you very much. I forgot to say that. Yeah. So basically, the mass of A is 3m, right? And the mass of B is m. Yeah. So the way we know that A will be going down, right, is due to the fact that it's heavier. Yeah. So I can just see that in the chat. So yeah, thank you very much, guys. You guys are fantastic for answering questions as well. Yeah. And another thing as well, the question says that before B reaches the pulley as well. That was a hint. So before B reaches the poly, well, that means it's going up. That means that one's going down. So these are the little things as well that you could just think of just to help you guys out. Yeah. Okay. Okay. Cool. And then now, let's continue. Well, oh yeah, they told us what tan alpha is, isn't it? Thank you very much, guys. I can see that in the chat. So let's do this here. We've got tan alpha. We've got tan alpha here. Got tan alpha here. So remember, this is alpha is acute, so we can just construct a right angle triangle to get expressions for sine and cos, can't we? Yeah. So remember, we've got this here. If I draw a right angle triangle like this here, this will be alpha, right? Now tan, just from Sokotoa, is the opposite divided by the adjacent. So that means that the opposite side is 3, the adjacent is 4. This is a 3, 4, 5 triangle. This is 5. Yeah. So if that's the case, then that means that sine alpha is just equal to the opposite over the hypotenuse, 3/5, and cos alpha is equal to the adjacent over the hypotenuse, 4/5. Yeah, so to be honest, when I'm doing this on my own, if I'm in an exam or something, I always get this out of the way first as well. Yeah, so now just to finish off completely, we're going to say, well, this is just 3mg, and then this is just sine alpha is 3/5, isn't it? Yeah, minus f minus t is equal to 3ma. So then tidying this up, 3mg times 3/5 is 9/5 mg, isn't it? Minus f minus t is equal to 3ma. And that's for 2 marks, to be fair. That all clear, guys? Yeah? Good stuff. All good? Okay. Okay. Cool. So that's fine. So let's have a look. Okay, so there's a couple questions. Yeah? F is friction. Yeah? No, you don't. I've seen the mark scheme for this one. It just says an equation of motion. Yeah? So even this, to be honest, in the mark scheme, I think they just put this for 2 marks. But just to be thorough, so this was only 2 marks. You don't need to figure out friction for now. Yeah. But anyways, let's continue. Now we've got part B here. Part B says show that the acceleration of A is 1/10 g. Now this is 7 marks. This is an easy 7 marks in my opinion, because all you're doing now is you're just going to find an equation of motion for particle B, and then just use simultaneous equations to figure out what A is. Yeah. So let's see what we've got here. All right. Now remember, we've got this equation here. I'm going to write this here again. We've got 9/5 mg minus f minus t. So let me write this out again. Minus f minus t. This is equal to 3ma, right? This is equation 1. Now let's get an equation of motion for particle B. Yeah. Now remember, it's going up the plane, so tension is going to be the one driving it up, and the weight is going to be dragging it down. Yeah. So it's going to be T minus mg, isn't it? Yeah. T minus mg is going to equal the mass times the acceleration. T minus mg is going to equal the mass. The mass of particle B was ma. So we've got these 2 equations. We need to figure out what A is. So we just need to solve this. Now, obviously, we can see here that this here is a problem here. I need to know what F is equal to. Yeah. But we know that F is always equal to the coefficient of friction times R. Yeah. So we need to figure that out. Do we know the coefficient of friction? Yeah. They told us the coefficient of friction between A and the plane is 1/6. So we know that mu is equal to 1/6, right? So F is equal to 1/6 R so far. Now, how do we find R? Well, R is the reaction force, isn't it? Which we can find just by resolving this. Yeah. So we're just going to put this here. Put this here. So it's just going to be, where is it? It's just going to be this one here, isn't it? R, let me just put this in a different color as well. If I resolve this, R will equal this one. These 2 are the same thing. Yeah. So I'm going to say R is equal to 3mg cosine alpha. Yeah. So now I've got that there. Well, R is equal to 3mg cosine alpha. Yeah. Now remember, cosine alpha was 4/5, wasn't it? Yeah. So R is equal to 3mg 4/5. And this is just equal to 12 over 5 mg. Let me just 12 over 5 mg. Yeah. And then now, remember, this is R. F is equal to 1/6 R. So all we're going to do here is we're going to say, well, F is equal to 1/6 multiplied by that 12/5 mg. Yeah. This is just equal to 12 over 6 is 2/5 mg. So now I have an expression for f in terms of m and g, right? I can plug this back in into equation 1. Yeah. So let me do this, huh? This is just going to be 9/5 mg. Now we now know that friction is 2/5 mg. So it's going to be 2/5 mg here. Minus T is equal to 3 MA. Does that make sense so far, guys? Where did the 1/6 come from? In the question, the question told us that the coefficient of friction between the plate A and the plate is 1/6. That's where 1/6 came from. Yeah. So it's quite a long-winded question. So I'm just taking bits and bobs. That all okay so far? Yeah, we all okay? Good stuff. All right. Now let's continue. Let's continue here. Now we've got this here. Remember, what is our job? We're trying to find out the acceleration. We're trying to find out what A is. Yeah. Now, if you look at this though, if you look at equation 2, the only problem here for me is this T, right? If I look at equation 2 though, I can rearrange to make T the subject. I'll do it right here. I can say T will just be equal to mg plus ma, right? And then that way I can plug this in here, and then I have an equation all in terms of mg's and ma's. That's perfect. Yeah. So let's do this. It'll be 9. Well, to be fair, I can simplify that, to be honest. 9/5 minus 2/5 is just 7/5. This is 7/5 mg. This is minus mg plus ma. Yeah, is equal to 3 ma. So therefore, tidying this up now, we're going to have 7/5 mg minus mg minus ma is equal to 3 ma. Now remember, we're trying to find out what A is. So let's move that minus ma over to the right. This will be 4 ma. And then 7/5 minus 1 is 7/5 minus 5/5. That's just 2/5, isn't it? Yeah, we got this here. So this is just 2/5 mg is equal to 4 ma. Yeah. Now remember, we're trying to figure out what A is equal to. So what can we do from here? Well, the m's will cancel. I can see m and m. So it becomes 2/5 g is equal to 4a. Now, if I divide both sides by 4, that's just the same as multiplying by a quarter. Yeah. So I have a quarter times 2/5 g is equal to a. Now this is just 2/20 g. 2/20 is 1/10. So that's it. We've got it. Let me just make sure. Yeah, 1/10 g. That makes sense, guys. That's 7 marks in the bag. Yeah. How do we find this question? Like, to be fair, nice, good stuff, easy, good stuff, good, great. I love pulleys, minor, good stuff, good stuff. Yeah. So all you're doing, guys, is just F equals ma. The same thing. If you see these connected particle questions, you're doing, you're creating 2 equations in terms of F equals ma for both particles. You're solving it simultaneously. It's the same thing each time. Yeah. Let's hope this comes up on Tuesday. So you've done that now. Now we've got a couple more to do in this question anyway. What is it? Part C says we need to sketch a velocity time graph for the motion of B from the instant when A is released from rest to the instant just before B reaches the pulley. Explain your answer. So we need to sketch a velocity time graph. Yeah. So let's do this here. Let's do this here. All right. Now let me draw an axis then. Velocity time graph. Right. Let me get an axis like this. Okay. So we know, for example, I'm going to put this as part C here. Yeah, this is velocity. This is time. Now we need to sketch a velocity time graph. And we worked out in part A, sorry, in part B, that the acceleration, right, is 1/10 g. So how do we do this, guys? Remember, A is a 1/10 g. What do we do? Exactly. Thank you very much, Antonio. Acceleration is constant. What is the acceleration in relation to a velocity time graph? It's the gradient. If I have a constant gradient, that's just a straight line. So all I'm going to do here is I'm just going to say, well, it's going to be this, isn't it? Whoops, not that. Sure. It's just going to be like this. Yeah. And then you can just say, well, m, the gradient, m is just 1/10 g. Yeah. And this is since A is constant. That's it. Done. Yeah. Exactly. It's linear. Fantastic. Yeah. All right. Now it says, in reality, the string is not light. State how this would affect the working in part B. So in reality, the string is not light. They told us that it was light and inextensible. How does that affect the working in part B? Exactly. Exactly. Thank you very much, Jazz, Dom. Exactly. Yeah, Ali, Yahya. The tension is not the same throughout, right? If it's not light, right? Remember, when we're dealing with these questions in mechanics, we're assuming that the tension is the same throughout the string. That is why we're able to solve simultaneously and get these nice equations. And that's why it's light. That's why it's light work. In real life, it's not that light. Yeah. We have to say that the tension will not be the same throughout. Yeah. So put this here. Part D, tension will not be the same. Will not be the same, be the same throughout the string. Yeah, that's how we'll affect it. Now, also as well, just a quick one. Remember with these part Ds, these one markers, right? They can ask you a multitude of things. They could say, for example, uh, state a one refinement to this model that you can make to make it more realistic, right? Now, what I always do with these questions, we've got these three things here. They can ask this in so many different ways. Yeah, in partly they just ask about attention, but all you would do, right, is you look at what they've modeled, what they've told you is being modeled, right, and then you'll just do the opposite. Well, how can I refine this model? The stones are modeled as particles. Well, let's not model them as particles, right? Stones are not actually particles of real life, right? The pulley is modeled as being small and smooth, right? The pulley could be rough. Yeah, the string is modeled as being light and extensible. Yeah, the tension will change. So stuff like that. So just have that in mind when you're doing these types of questions, that they're always going to ask you that one marker at the end of these. Yeah, is that clear? Air resistance. Thank you very much. Exactly. Exactly. Thank you very much. Yeah, good stuff. Okay. 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 So I've got a couple questions. I'm gonna make sure I get through them. Yeah. So if you guys can help me out and just answer the questions, I'm just gonna continue. All right. So we've got this one. Now we've got moments. We've got moments. Now, guys, moments is everybody's favorite topic. So I want you guys to tell me in the chat, put a 0 if you're thinking moments, get out of my face. Put a 10 if you're thinking, I love moments. I wish the whole paper was moments, because we all love moments, don't we? -9, 0, 0, 7, 10. Get out of my face. Genuinely. 0, 10 now, thanks to you. Oh, you're welcome. You're welcome, Renee. I hate moments. Okay. So lightweight. Okay. So let's have a look at this one here. Yeah. All right. There's a lot of messages. Okay. 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 I've got an answer about part B. I'll after at the end, we're definitely gonna do it. Let me just what was part B? Just quickly. So just before we go back, because I just saw something about part B. Part B was that the 7 marker? Okay, I'm definitely gonna go over this again at the end if there's time, because there's a couple of us about part B again. But it's just F equals MA, solve it simultaneously. Yeah. If anybody can help anybody out for asking about part B, that was just a 7 marker. That would be much appreciated. I'm just gonna try and get through as much just before the hour. Yeah. Anyways, so let's read this one. It says a beam AB has mass M and length 2A. The beam rests in equilibrium with A on rough horizontal ground, rough friction, with B against a smooth vertical wall. The beam is inclined to the horizontal at an angle theta as shown in figure 2. The coefficient of friction between the beam and the ground is mu. The beam is modeled as a uniform rod resting in a vertical plane that is perpendicular to the wall. Using the model, we need to show that mu is greater than or equal to a half cot theta for 5 marks. Yeah. Now, let me get this diagram here again. Yeah. Now, when we're dealing with these types of questions, right? These ladder questions, these moments and stuff like that. First things first, you want to label your diagram. You want to draw a force diagram. Yeah. Now, this is a beam, right? It's a beam actually, yeah, of mass M, yeah? And it should say, yeah, the beam is modeled as a uniform rod. So that means that the weight acts down the middle, acts down the center, yeah? So what I'm going to do is we'll say, well, it has a mass of M. So I'm going to put, let's just say this is like roughly in the middle here. This is going to be mg, like this, yeah? Now, what else do we know? Well, what else do we have here? It's the beam rests on a rough horizontal ground, right? So there's friction on the ground, yeah? So first things first as well, there's a point of contact here. There's going to be reaction force here for sure, right? I should actually make these a bit better to be fair. And now just a quick one, guys. This friction is in equilibrium right now. Which way is the friction going to act? Is it going to act to the right? Is it going to act towards the wall or to the left? What do we think? Exactly. It's going to act to the right. Always acts to the right, towards the wall. Yeah. The way I like to think of it as well is that if it's an equilibrium right now, if this was to drop, right? If this was to drop down like this, then it would get flatter, wouldn't it? Right? This part would go that way, wouldn't it? If it was to drop, if this was to collapse, it would go to the left, meaning that friction must act to the right. That's how I always think of it. Yeah. But yeah, we've got this so far. Now, are we all done, guys? Any other forces that I need to label? Exactly. Reaction at the wall. Exactly. Thank you very much. Yeah, there's another point of contact here. Now, remember, reaction is perpendicular to the plane. This is a vertical plane. What is perpendicular to a vertical line? A horizontal line. So for sure, we're going to have a reaction at B, which looks like this. Yeah. And I'll call this RB. I'll call this RA and I'll call this RB. Yeah. Now, this looks fine to me in terms of the force diagram. I think this is all okay. Yeah. Now, what does the question say? The question says, show that mu is equal to a half cot theta, right? Now, even if I don't really know what's going on here, think of the hints that's given in this. I can see mu and I can see a greater than or equal sign inequality. Where do we see that come up in mechanics? Where do we see that come up in mechanics? Where you see mu and a greater than, and it doesn't even matter if it's greater than or equal to, because you can just flip it around. Exactly. Limitum equilibrium. Yeah. F max is equal to mu r. Exactly. Or F is equal to mu r. Yeah. So we're going to say F here is less than or equal to mu r. This is just a fact. So for me, the way to go about this type of question is, okay, well, let me try and find an expression for the friction. Let me find an expression for the reaction, right? And then somehow, if I get these expressions here, hopefully algebraically, I can somehow manipulate it to get what they want. Does that make sense as a plan of action, guys? Does that make sense? Yeah? Good stuff. Yeah? Good stuff. All right. So, continuing now. So, what do we have here? Well, we need the reaction, right? For sure. And if I resolve vertically like this, right? Well, I can see that I've got this reaction here. Yeah. I've got this reaction here. Yeah. And this reaction here. And notice I'm using this reaction, right? Because we've got friction acting here. So I have to use this one in this formula. Is that clear? Because there's two reaction forces. So somebody may be thinking, why am I using that one instead of the one there? Because we're dealing with friction here. There's the wall was smooth, they told us. They told us that the floor was rough. So that's why I'm using this one. Is that clear as well? Yeah, because that's another question that I think people would ask as well. Yeah. Okay, good stuff. All right. So now resolving vertically, I'm going to say that, well, R is equal to mg. Yeah. Those are the only two vertical ones. So that's fine. I know what R is. I'll take that. And then what else can I say? Yeah. Well, I can say, for example, what I always do anyway, I always resolve vertically and horizontally. Hopefully that will help us out. But yeah, got this here. We've got this frictional force here. We've got this one here. Yeah. So I can say that that one, F is equal to RB so far. Yeah. All right. So now what we need to do with something like this is we need an expression for the friction. Yeah. Now, remember, this is a clear moments question, right? So what you want to do is, remember, moments tells you that you can take clockwise forces and anti-clockwise forces and make them equal to each other. So we can get equations for that. Yeah. So what we're going to do is we're going to take moments, right? We're going to take moments about A. With these questions, it comes up all the time. Always take moments where there are more forces happening, because when you take moments there, the reaction force and the friction force will be disregarded. Yeah. So we're going to take moments about A. Let's take moments about A. Yeah. Now, the way I do these questions, right? So if we're taking moments about A, right, there are two forces that we need to take into consideration. This force, mg, the one going down, and this reaction, the reaction at the wall at B. Yeah. These are the only two, because RA and F are at A. So they're going to be disregarded. Yeah. So let's do this now. Now, remember, the definition of a moment is the force multiplied by the perpendicular distance. Yeah. So the way I always do these questions, right, is like this. So what I'm going to do, just to make it a bit more clearer, wow, an hour goes by so quick. What I'm going to do here is, this is theta here, right? Like this. And then remember, this mg, remember the beam was uniform, so this acts directly in the center. So that means the hypotenuse would be half of 2a, which is a. Yeah. And then we've got this force acting downwards like this, right? I always just do this like this. Yeah, this is the mg force, and this is a right here. Yeah. Now remember, there are clockwise forces and there are anti-clockwise forces. So if I want to find the moment, right, for this mg force here about a, right, well, it would just be the perpendicular distance, which is this one here, right? Can somebody tell me in the chat, what is this force equal to? Remember, be careful. Oh, remember, guys, remember. Now, we're looking for a distance here, yeah? Not a force, yeah? Because I need to figure out what the distance is. So I'm not going to use mg for now. Is that clear? Yeah? This distance, I may have said force if I did, apologies. But I'm looking for this distance here. This will just be a cosine theta, isn't it? Yeah? This distance, sorry, in green is a cosine theta. Yeah? Now, if I swing it round, right? Is this clockwise or anti-clockwise? Exactly. It's clockwise for sure. Yeah, it's clockwise. So therefore, the moment of this mg force would be the force, which is mg, multiplied by the distance to get there, which is a cos theta. Yeah. So therefore, I'm going to put this here. I'm going to put mg a cos theta here. Yeah. And then we've got the anti-clockwise force to go. Yeah. Does that make sense, guys? I want to make sure we're all okay with that. Yeah. Good stuff. All right. So we've done that force. You guys, I can see in the chat, you guys are helping me out answering questions. I really, really, really appreciate it. Yeah. Thank you so much. Now, we need to figure out the moment at B. Yeah. Now, what I do with this one here is, well, what I'm going to do, I'm going to swing this round like this. Yeah. I'm going to extend this force here. This is how I always do it. Let me extend this force this way, like this, right? This is just the same force, like this. I'll call this RB. And you're going to see why I'm doing it, right? This is the force RB here. Yeah. Now, if I want to, we'll do it here again. This. And then remember, we want the moment about A, right? So can you see, if I was to draw a red line like this, and I make it vertical like this here, right? Can you see, right? The perpendicular distance is just that red line. And this is the force acting in that direction, RB. And I would swing it this way. Does that make sense, guys? I would swing it this way, and this is anti-clockwise. Yeah. So we just need to figure out what that vertical distance is. Does that make sense? Yeah. Good stuff. Good stuff. Exactly. Yeah. So what is that distance though? Well, remember, the whole thing is 2a, right? So if I put a right angle here, that means that this, remember, this is opposite the angle. This would be 2a sine theta, wouldn't it? This distance, I'll highlight it in green. The two distances in green are exactly the same thing. Yeah. Does that make sense, guys? Yeah. Thank you very much. Fantastic. Yeah. So that means that the moment for RB would be the force, which is RB multiplied by 2a sine theta. Yeah. So let me put this here. Put this out just quickly. This would just be how? This would be RB times by 2a sine theta. Yeah. So therefore, I'm going to put this here. I'm going to put RB times 2a sine theta. Yeah. Like this. Does that make sense, guys? Yeah. All good so far? Yeah. Perfect. Okay. So now remember what our job is, though. Remember, show that mu is greater than or equal to half cot theta. Our job was to find an expression for the reaction force, which we've done, mg. Find an expression for the friction, which we know is RB. But why are we doing this moments? Because now we have an equation in terms of RB that we can rearrange. And in that way, since F is equal to RB, we make that equal to F and then plug in, and then hopefully we should get that inequality there. Yeah. So tidying this up now, Well, what do we have here? Well, if you've got this equation here, and I want RB, I'm just going to literally divide both sides by 2a sine theta, aren't I? So I've got cos theta here, and I'm going to divide this by 2a sine theta here. Yeah? This is RB. Now, hold on, I forgot the a here, to be fair. This is an a here. Yeah? So we can see that the a's cancel out. So let me put this here. I could have done it before, actually. These two a's cancel out here. Goodbye, goodbye. Now I've got a 2 on the bottom. That's 1/2. I've got an mg on the top. That's mg. And can somebody remind me, please, what's cos over sine? Exactly, cot. Wow, you guys are quick. You guys are quick. Cot. Thank you very much. Yeah. So now we have an expression for the reaction at the wall, but that's perfect because the reaction at the wall was equal to the friction because we resolved it horizontally. So if that's equal to RB and F is equal to RB, I can say, well, then that just means that the friction is equal to 1/2 mg cot theta. Yeah. So then what does that mean then? Well, remember what the whole point is. Remember when you're doing these show that questions, you have a goal in mind. Our goal was to find an expression for F, find an expression for R. We've done that. Now we hope to see when we algebraically manipulate it, we get that. And we should do because we've got a 1/2 mg cot theta that looks perfect. Yeah. So let me just grab all of this. Grab all of this here. 1 second. Let me just grab all of this here. Okay. So I've got this here. All right. Now paste in this here. All right. So let's see. Well, we know that F now is that. So I'm going to say, well, F is that a 1/2 mg cot theta. And then less than or equal to mu times by the reaction force. And at the very beginning, we said that R is equal to mg. Yeah. So we got this here. Well, what happens now? Well, clearly the mg's cancel. I've got a 1/2 cot theta is less than or equal to mu. And then obviously that's just the same as saying that a mu is greater than or equal to a 1/2 cot theta. And we're done. Yeah. How do we find that, guys? Easy. I just say we completely forgot that we could sub I back in. Yeah, easy stuff. Yeah, delicious. Meh. Don't worry, guys. Just practice this. Yeah, it's the same thing that you're doing. Yeah, he's going to carry the books. Okay, so just the last thing that I'll explain again. So remember, what we've done here is remember, we got this here from our heads. We know that F is less than or equal to mu R. Our job is to find an expression for F, a 1/2 mg cot theta, an expression for R, mg. Yeah, R is equal to mg. All we've done is we've just plugged these in. Let me just color code this so you know. This here is the friction. Yeah, this here is the reaction. We just rearrange it and we get that. Yeah. So you've done that now. What's the time? Oh my days. I haven't even done the projectiles question yet. Sorry, guys. I know some of you guys may have to go at 1 o'clock or stuff. I know I always overrun. Apologies. So if you need to go, don't worry. It's going to be uploaded to YouTube. So yeah. But anyways, let's do the next one. So we've got this here. Now let's see this one. Paste. All right. Now, what does it say here? It says a horizontal force of magnitude kmg, where k is a constant, is now applied to the beam at A. This force acts in a direction that is perpendicular to the wall and towards the wall. Given that tan theta is 5/4 of mu is a 1/2, and the beam is now limited in equilibrium, using the model to find an equation, the value of k. All right, cool. So let's get this diagram here again quickly, because there's a lot going on now, isn't there? Yeah. So pasting this here. All right, now let's get what we know very quickly now. The reaction is, the weight is still the same. This is still mg. There's still going to be a reaction at the wall here. We'll call this RB. There's still going to be a reaction at A because the floor is still rough. Yeah. But they've told us now that there is a horizontal force of magnitude kmg, where k is a constant, is now applied to the beam. This force acts in a direction that is perpendicular to the wall and towards the wall. So if it's perpendicular towards the wall, right, that means that that force that they're referring to must be acting this way, right? So this is going to be kmg for sure. Yeah. What about the friction? Which way does the friction act? You guys are just having a chat. Lungang. This is so funny. Yeah, exactly. It's gonna go the it's gonna go the other way. You guys are hilarious. So it's gonna go the other way, yeah, because the KMG is acting towards the wall. So we're gonna do it the other way. Yeah. Shout out Neil does maths. Great guy, great guy. I've seen his videos. Lungang, Lungang. Okay, so it's gonna act this way, yeah. Okay, so now we've got this here. Now we need to what does it say? We need to use the model to find the value of k. They've told us that tan theta is 5/4. Tan theta is 5/4, and mu is a half. Yeah. Now we need to find the value of k. So it's the same thing in the sense where if we're trying to find the value of k, right? How do we find values of anything? We need to solve equations. So we need to create equations. Yeah. So what we're going to do is the same thing. Let's resolve vertically and horizontally. Yeah. So this is going to be what do we have here? Well, if I resolve vertically, oh, it's just still these two. That's fine. Yeah. RA is still going to equal mg. And then we've got these ones here. This one is going this way. This one is also going this way. And this one is going that way. Yeah. So therefore, we're going to say, well, that what we're going to say? We're going to say RB, right, plus F, because they're going in the same direction, is equal to KMG. Yeah. So we've got these two equations now. Now remember, what we're trying to do is we're trying to find K at the end of the day. So our job, right, is to figure out RB and F, and then hopefully that will help us to get K. Yeah. So we know that it's now a limited equilibrium. So F is equal to mu R, right? So we've got F is equal to mu R. Yeah. They've told us that mu is a half. We can find the reaction force. So let's do this. We're going to say F is equal to a half, right? RA, remember, because we're dealing with a rough surface on the floor, so I need RA, which is equal to mg, isn't it? Yeah. So it'll be a half mg here. Yeah. So now I'm going to plug this in here. I've got RB plus a half mg, yeah, is equal to kmg. Yeah. Now we need to figure out what RB is. Now we can do this again because we can just take moments, can't we? Yeah. Now, if you think of it though, if I take moments, we're going to take moments about A again. Yeah. F, RA, and KMG are all going to be disregarded because we're taking moments about the point. So it's just literally going to be these two again. Let me take moments. It's going to be these two, MGs and RBs. Yeah. So it's going to be the exact same moments equation. So I don't need to do it all again. I'm just going to get up. Yeah. Let me just check the chat just to see all okay. Okay. Yeah, thank you very much, guys. Again, you guys are all being very helpful and answering questions in the chat. So all I'm going to do now is just get this equation here again because it's the exact same moments formula. Yeah, because that way I'll be able to get an equation, an expression for RB, right? Plug it in into this, and that will give me K. Yeah. Does that make sense, guys? We all okay with that? Trying to make sure we're all okay with that. Yeah. Okay. Cool. Good stuff. All right. So now continuing now because it's this exact same moments equation. What do we have here? Yeah, well, RB then, the same way, right? Well, if I divide it again, it will just be a half, right? The 2 will go, the A's cancel, will be mg, and it'll just be cot theta. Yeah, but they told us though, they told us that tan theta is 5/4, didn't they? Yeah, if tan theta is 5/4, what's cot theta? You guys are just all just having a chat. Exactly. Thank you very much, guys. It's 4/5, isn't it? Yeah. So that means cot theta is equal to 4/5. So therefore, we're going to have a half mg times by 4/5 is equal to RB. Now just tidying this up. What's this? This is going to be 2/5 mg is equal to RB. Yeah. So now we're good, right? Because remember, the whole point was to find expressions for RB and F. We now have that. Now that will allow us to figure out what K is. Yeah. So copy, paste here. So we got this here. All right. Now, RB is 2/5. I've got 2/5 mg plus a half mg is equal to kmg. Yeah. Now, what do I have here? Well, I've got mg, I've got mg, I've got mg. They all cancel out. So it's just going to be 2/5 plus 1/2 is equal to k. And what's that? This is just, what's that? That's a 10 there. That's a 4, right? And then that's what? 10 there. And then that's 5. Yeah. 4 plus 5 is 9. 9 over 10. K is equal to 9 tenths. Make sense, guys? You could use a calculator, forget. You could use a calculator, can't you? Yeah? Good stuff. Good stuff. How's that for 10 marks? Is that easy 10 marks? Is that, listen, this is 10 marks. Quick, let me get my A star. Yeah? Easy marks. All right. Good stuff. Good stuff. Good stuff. All right. Now we've got one more. What's the time? 1 o'clock. Jeez, jeez. Sorry about this, guys. I try to do it as fast as I can. So we got one more, projectiles. Yeah? Now, how do we find projectiles, guys? Put a 0 if you're thinking not a chance, get this out of my face. Put a 10 if you're thinking, listen, 110%. I can see 1,000, I can see 8, I can see peak physics going up right now. I can see 0 now, guys. Trust me, projectiles are easy. Love them. Projectiles 8. It's fine. Okay. Okay. Okay, cool. So I can see a couple of questions about the other ones. Don't worry, I'm going to try my best to just go back after I finish all of these questions. Yeah. So let's look at this one here. Now, it says a golf ball is at rest at the point A on horizontal ground. The ball is hit and initially moves at an angle alpha to the ground. Yeah. The ball first hits the ground at the point B, where AB is 120, as shown in figure 3. The motion of the ball is modeled as that of a particle moving freely under gravity, whose initial speed is u meters per second. Using this model, show that u squared sine alpha cos alpha is 588. So what I've got here, actually, a shout out to one of my students because she told me about this. What you guys can do is you can construct the table with your horizontal and vertical motions of x and y, yeah, and your initial and final velocity, yeah. Has anybody seen a table like this before? No, no problem. Okay, I can see yeses and no. So what you can do with this table, right, is basically, let me just explain it very quickly. For x's, right, well, we know that the initial and final velocity is the same, right? The same, and obviously the distance, right, is just going to be distance times time, isn't it? Yeah. And then we've got the vertical component, right? The initial vertical component of velocity is u sine theta, and then the velocity at any time is just v equals u plus at. Remember, a is equal to minus g because we're dealing vertically, and then the distance is s equals ut plus half at squared. So it's just summarized for you. So if you just remember this table, right, it will help you just answer these projectile questions quite quickly. Yeah. So got this here. Now let's continue. So we need to show that u squared sine alpha cos alpha is 588. Yeah. So there's a couple ways to do this. What you want to do essentially is you just want to construct equations for both the horizontal motion and the vertical motion, and obviously just use algebra to rearrange and manipulate. Yeah. So no, this table is not for just this question. This table is for projectiles in general, for that question I just saw in the chat. So what can we see here? Yeah. Now, the first thing I can see here is that, well, if I want to express the horizontal motion, right? Now, it starts from A, right? And it goes all the way to B, yeah? So we can just say, well, the distance it covers is 120 meters horizontally. And we know that the definition of that is just U, and in this case, it's alpha, cos alpha, right? I'm going to write this as this, times T. This will just equal 120, yeah? And then now vertically, well, it starts at A, which is 0, and then it goes back to 0. Yeah. So that means vertically, it must just be at 0 when it gets to B. Yeah. So therefore, I'm going to say, well, remember this one here, using this formula here, right? We can just say, well, U sine alpha, right? UT, yeah. And then minus 4.9 t squared is equal to 0. Yeah. Does that make sense so far, guys? Yeah. All I've done is I've just constructed an equation for the horizontal motion and the vertical motion. Yeah. That okay? Just gonna wait for anybody to say so I know we're okay to continue. Yeah. Good stuff. Good stuff. All right. Now, so what you want to do then is, remember, we're trying to show that u squared sine alpha cos alpha is 588. Now, there's no t's there in that show that. So for me, what I want to do is maybe get an equation or get an expression for t, right? plug that in into one of them, that will eliminate t. That will just give me sines and causes, right? So we can see that from this one, yeah? We're going to see, well, from the horizontal motion equation, right? If I rearrange that, that will just tell me that t is just equal to 120 over u cos alpha, yeah? So now I've got an expression for t. I'm going to plug this back in into the second equation, the vertical motion, yeah? So that will tell me that, well, that will be Vm will be u sine alpha, right? And then it will be t, which is 120 over u cos alpha, yeah? Minus 4.9, and then it will be 120 over u cos alpha squared, yeah? Just make sure it's all okay, is equal to 0, yeah? Okay, so now let's continue now. Let's just see. So remember, this is a show that we want to get to, yeah? Always have in mind the show that you're trying to get to. So let's just do this very quickly. What's the time? 1:04. Okay. So yeah, doing this one here. Right, remember, this is what you're trying to get to, yeah? U squared sine alpha cos alpha is 588, yeah? We've got this here. So let's tidy up as much as we can, yeah? What can we see? Well, this one here, well, the u's will cancel out from this one, right? So that will go. And then, well, I've got sines and cosines. Although I have a sine on the top and a cos on the bottom, which I can make tan, I don't see that in my show that. So I'm just going to leave it like that for now, yeah? So that way, this will just become a 120 sine alpha over cos alpha, yeah? And then now let's tidy this up now, because we've got minus 4.9 times by, and then if I square this fraction here, yeah? If I square this fraction, well, 120 squared is what? So 120 squared is 14,400. 14,400 here, yeah? Over, now if I square the denominator, that will be u squared cos squared alpha, right? Is equal to 0, yeah? Now what I'm going to do, I'm going to tidy up. I'm going to tidy up and see what happens, yeah? So the first one I'm going to tidy up is this thing here. I've got this 4.9. I've got this 14400, yeah? So let's tidy that up. I'm just going to do answer times the 4.9. This will give me 70,560. So that will be, put this here, that will be 70,560 over u squared cos squared alpha, yeah? Equal to 0. And then I've got this here, sine alpha over cos alpha. All right. Now remember, we're trying to show that u squared sine alpha cos alpha is equal to that. We don't have any fractions here. So what I would do, right, is for me, it makes sense to just multiply everything. So the fractions, so the denominators cancel, right? And what I can do, obviously we've got a u squared there. So it would make sense for me, right, to multiply every single thing by this one, because if I multiply everything by this one, it will cancel with that cos alpha on the left anyway, so it's fine, yeah? So I'm going to multiply everything by u squared cos squared alpha, yeah? Well, that will give me 120 u squared cos squared alpha, right? And I've got the sine alpha here, and then I've got this cos alpha, right? Like that. Remember, this one there is going to cancel with one of them. So straight away, this just becomes 120 u squared cos alpha sine alpha. And I'm just going to write the right way around. I'm going to write sine alpha cos alpha just because that's what they've got in the show that, yeah? Like this here. And then this is just minus 7,560, which is equal to 0. Yeah. Now remember, we need to show that u squared sine alpha cos alpha is that. So that's pretty easy now. We're just going to say u squared. No, let me move this. I'll do it in steps. So we're going to do u squared sine alpha cos alpha is equal to 7,560. And then we're just going to divide that, aren't we? Cos alpha is equal to 7,560 divided by 120. Yeah. Put this into my calculator. Answer divided by 120. 588. Perfect. Yeah. Sine alpha cos alpha is equal to 588. That makes sense, guys. Yeah. Good stuff. Good stuff. Yeah. Okay. So just a quick one as well. So I'm going to explain this table after. Let me just finish the question. There's a couple of questions I see in the chat. Now, what does this one say? Part B says, put this here. It says the ball reaches a maximum height of 10 meters above the ground. Show that u squared is equal to 1960. Yeah, so all right. So let's get this diagram here again. Yeah, got this diagram here. Okay. Well, it reaches a maximum height 10 meters above the ground. So maximum height is going to be here. And this apparently is 10 meters. Yeah. Now, what do we know about the velocity at this point, guys? Exactly. V equals 0. The maximum velocity, the maximum height, the velocity is 0, right? Because it's just about to change sign, isn't it? Yeah. So therefore, for me, this is just suvat, to be honest. Well, I know that, for example, V is equal to 0. What do we know? S is equal to 10. Yeah. And then we're dealing vertically. So the vertical component of the initial velocity, right, will just be equal to, I'll say uy. This will just be u sine alpha, isn't it? Yeah, capital U, to be fair, because it's a capital U. Yeah, and then the acceleration. Remember, we're dealing in a vertical plane. We model it as going upwards, so the acceleration acts downwards, so it's minus g. Yeah, so I've got this here. Yeah, I've got V, S, U, and A. Now, doing suvat, can somebody tell me what equation connects all of these? That's what you do with suvat. So can somebody tell me? Exactly. Thank you very much, Dom, Taffy. Fantastic. V squared is equal to U squared plus 2AS. Yeah. V squared is equal to U squared plus 2AS. So all you're going to do now is just going to plug everything in. Yeah. So we know that this is just going to be 0 squared. This is going to be U squared sine squared alpha. Right? If I square U squared sine squares, they square, U squared sine squared alpha, and then plus 2 of minus g and then s, yeah, which we know is 10. So we get this here, yeah. So now this is not too bad because this here is I think that's 196. Let me just double check. This is a 2 times minus 9.8. G is minus 9.8. I've got 2 negatives there, sorry. And then times it by 10. That is equal to minus 196, isn't it? So I've got 0 is equal to u squared sine squared alpha, right? Minus 196. Yeah. So that means for me that I've got u squared sine squared alpha is equal to 196. Yeah. Now remember, the question is asking us to show that u squared is equal to 1960. Yeah. So I've got this here. This is what we're trying to show. Yeah. And then for me to do this, well, I would need to find an expression for sine alpha. Yeah. If I can find an expression for sine alpha, or a value for sine alpha, I should say, then I can hopefully get an answer that will give us 1960, right? If I divide by that. Yeah. Cool. So let's see what we have here. Now remember, these questions are always linked together. Yeah. So we've got this here that we were given in part A. So let's just get this here. Right? Copy. Paste here. All right. So we've got this here from part A, and we've got this. Now we're trying to figure out what u squared is. Yeah, we're trying to show that it's 1960. So what we could do maybe is say what we could do from here. Maybe if we what if we divide by this one? Let me just see what would be the best way to do this one. Maybe if we let's just see. Let's say, for example, if I say sine squared alpha, maybe, is equal to 196 over u squared. Yeah? That's sine squared alpha. So if I put this in here, maybe that will help us. I'm just trying to think what will be the best way to do this. We're trying to get sine alpha. So maybe if I do or what if I find an expression for u? No, let me find an expression for u because then I can just plug it into there. Probably. Yeah, let me do that. Let me do u squared is equal to 196 over sine squared alpha, and then plug it into there because that way that will eliminate u, wouldn't it? Yeah. So I'm gonna plug this into there, So that will give us 196 over sine squared alpha, right? And then that's fine. That's u squared, that's fine. And then sine alpha, cos alpha. Yeah, that's perfect, isn't it? 588. And then what do we do now? Well, tidying this up, we've got 196 here. Sine on the top, 2 sines on the bottom. That's going to be sine on the bottom, like this. And then I've got a cos alpha here. And this is equal to 588. Now, what do we have here? Well, we've got a cos on the top, we've got a sine on the bottom. This is just cot, isn't it? So I'm going to write this as 196 cot alpha. Yeah, just a quick one. Cos over sine is cot. So I can just rewrite it like this. Like this, 588. Yeah. And then now, that means, well, cot alpha will just be equal to 588 over 196. Let me do this here. Just make sure you guys can see my calculator. 588 over 196. This is equal to 3. Yeah? Well, if cot alpha is 3, now remember, we're trying to find an expression for sine alpha, right? What you could do is, well, say, well, if cot alpha is 3, then I could say, well, tan alpha is just a reciprocal of that 1/3. Yeah? Now remember, from our diagram, alpha is a cube. I can construct another right angle triangle like this. Like this here. This is alpha. Tan is the opposite over the adjacent. So 1 will be here, 3 will be there. And then obviously this one here will just be the square root, Pythagoras, of 1 squared plus 3 squared, which is just equal to 1 plus 9, which is equal to root 10, isn't it? Yeah, 1 plus 9 is 10. Yeah, that's perfect. This is root 10, right? So then, therefore, remember the whole point. We're trying to find the expression for sine alpha, because remember, we got here sine squared alpha. U squared sine squared alpha is 196. Yeah. So let's find the expression for sine alpha then. Will just be, whoops, need to get rid of that. One sec. Sine alpha will equal, well, it's the opposite over the hypotenuse, isn't it? 1 over root 10. So if that's sine alpha, that means sine squared alpha, right? Is just the square of that. Square the top 1, square the bottom 10. Sine squared alpha is a 10th. So therefore, what do I have here? Remember what we did when we used Suvat? We got a here, didn't we? We are here. Copy. Paste this here. And then we've got this here. This is what we're trying to show. Yeah? Well, this is easy now because we've got this here. We know that sine squared alpha is a 10th. So we're just going to say u squared 1/10 is equal to 196. Times both sides by 10, we get u squared is 1960. Done. Make sense, guys? This paper was 2022. Yeah, all good? All good? Yeah? Okay. So we're pretty much done. Let's just there was like 2 1 markers. All right. Now it says in a refinement to the model, the effect of air resistance is included. The motion of the ball from A to B is now modeled as that of a particle whose initial speed is v meters per second. This refined model is used to calculate the value for v. State which is greater, u or v, given a reason for your answer. So remember, initially there was no air resistance in this model, right? Now they're saying that we're going to include air resistance. Which value is greater, u or v? I want you guys to tell me in the chat, please. No, they weren't all from 2022, by the way. Surely you. Okay. Now, you can see a lot of us are saying you. This is like a bit of a trick question, right? The answer is actually V. Yeah. The reason why is this. So when you're dealing with these modeling questions, right? What you're actually saying is, well, we have this model here. It's telling us that it goes from the point A to the point B, right? In a certain amount of time. Yeah. And it's 120 meters. Yeah. Now, remember, this is the model. This model has been refined. So this hasn't changed. The particle still goes from A to B in a certain time and this distance of 120. Yeah. Now, if there's air resistance included, right, and it still will reach it in that same time, what must happen to the speed of the particle initially? It has to get faster to overcome the air resistance to then make sure the model is still fitting in. Does that make sense? Does that make sense? It's actually V. Yeah. I'll repeat that. Yeah. So basically, it's come up quite a lot, to be fair. I've seen it in a couple of papers, but we have this model here. Yeah, it starts at A, it goes to B in a certain amount of time. Remember, they said that the model has been refined, right? So the model is still the same overall in terms of it's going from A to B, the distance horizontally is 120, it's going to get there in a certain time. If there's now air resistance included, right, for the particle to travel within that same amount of time, it would have to travel faster, wouldn't it, to overcome the air resistance? Does that make sense? So the initial speed of V must be greater than U, because for it to be able to reach it within that same time, it would have to be faster because there's now air resistance. Does that make sense? Exactly, yeah. Yeah? Okay. So therefore, just to finish off, what was this part C? V is greater. Yeah? The particle, sorry about my handwriting, guys. The particle would have to, I should have typed it to be fair, would have to overcome, I'm going to write air resistance. I can't spell resistance, sorry guys, resistance, yeah? Resistance in the same amount of time. Perfect, yeah? Now we've got one more. D. State one further refinement to the model that would make the model more realistic. So what's this one, guys? One marker. The motion of the ball is modeled as that of a particle. It's moving freely under gravity, blah, blah, blah. What would be a further refinement? Exactly. Yeah. You could account for the spin. There could be rotational symmetry. The ball, don't model the ball as a particle. Exactly. Remember what I told you when you're dealing with these questions. When you're actually reading the question, what I'm doing when I'm doing mechanics, the ball is modeled as a particle. So for me, if I see that one marker at the end, which I can see right here, I know that I'm just going to say, don't model the ball as a particle. There's loads of different things. Yeah. Use a more accurate value for G, so on and so forth. Does that make sense, guys? Spin, exactly. Take into account the dimensions of the ball. Yeah, if any of you do further mechanics, there's a couple of topics that do that anyway. Yeah. Okay. Cool. Again, I've overrun. Sorry, guys. These questions take a long time to explain. But how are we all feeling, by the way? Feeling a bit better for applied for mechanics part anyway? Yeah, bit better. Cool. Cool. Very well explained. Thank you. Thank you. Now you're welcome. Mechanics over stats any day. Yeah, I was gonna ask you guys, what do you prefer? Stats or mechanics, guys? Mechanics hate stats, mechanics so clear, stats obviously, stats easily. To be fair, I'm a bit of a stats guy, to be fair, myself. Okay, cool, cool. But yeah, so yeah, hope that was all helpful. What now? I think there was a couple questions. If you can just let me know, or I hope you guys helped out with the questions. Yeah, and yeah, what I'm gonna do, this is the table, just a quick one. Let me just explain this table again. Let me just zoom in. So basically, what you're doing here with this table, to be fair, I didn't really explain it that well, but basically, you have your components for X or your horizontal, right? And you have your components for Y. So remember, the speed initially of the horizontal component is u cos theta or u cos alpha, whatever angle they use. I remember that doesn't change. The velocity, the final velocity is the exact same thing. Yeah. So this is that part for the horizontal. And then we've got the distance here, the displacement, right? This is just distance times time, isn't it? Yeah. So that's that for X. And then for Y, right? Because we're dealing vertically now, obviously the initial speed is u sine theta, right? The vertical component of the velocity, the initial velocity. Now remember, when you're dealing vertically, you have to use your Subat formulas, right? So all you're doing, so all this one is here. This is just v is equal to u plus at. Yeah. Remember, your vertical component of speed initially is u sine theta. Your acceleration due to gravity is minus 9.8. Yeah. And t is time. Yeah, so all I've done here, or not me to be fair, let me not take credit, this isn't my table. Shout out to my student. All they've done there is just put this in here. Yeah. And then now remember the displacement is just S is equal to UT plus a half AT squared. Yeah, that's all you've done here. Does that make sense? Remember, A is 9.8 minus 9.8. So if I half, that'll be minus 4.9. Is that clearer? Yeah. Okay. In the ladder clue for second part. Okay, just quickly as well for ladder question. In the ladder question for the second part, can you explain what you did briefly? So all I did here is, remember they told us that it's now an equal limit in equilibrium, so F is equal to mu r, right? All I've done here is that I've just created an equation because it asks us to find the value of K. All I've done is just create an equation, right, in terms of K to solve it. Now remember, when we resolve horizontally, right, we get, if we look at the green ones, right, the two ones going to the left are RB and F. So it's RB plus F, and the one going to the right is K and G. So I get this formula here, and then all you're doing is finding expressions for RB and F, plugging it in and then solving that equation. Obviously, I needed to take moments about A again to get an expression for RB that I can then plug into this equation here. So the key basically of this one is this here. Yeah? Cool. Why was F going left? Because K was acting towards the wall now. So remember, friction opposes motion. So if they're saying that K is acting towards the wall, right? Then if it was to move, then friction would be acting towards, away from the wall, to the left. Yeah? Does that make sense, guys? If you guys have other questions as well, I'm going to be putting this on YouTube so you can watch this all again. Yeah? But let me just quickly, before I let you guys go, let me just see what I've got here. Okay, yeah. Just a cheeky plug, you know, I was watching Drake. But anyways, cheeky plug. This is my YouTube channel. Yeah. So if you want to watch it later on, then it's going to be on my YouTube channel. I'm going to just put the link to the chat. So I'm nearly on 1K, guys. So if you're watching this on YouTube, like, comment, and subscribe. I don't know if you guys remember, if you guys were here last week, I was on about 600. So you guys have been very, very supportive. I really, really appreciate it. Yeah. Also on TikTok as well. So if you want to follow me on TikTok, I'm also on Twitter and Instagram. Yeah. And also this website as well is called Exam Q. It's a really good website. I'm going to put this in the chat now. Let me put this in the chat now. This is really good. I'm sure a lot of you know it. Let me put this here. This is a really good website. Basically, it filters what topics that you want to go over. Yeah, it's really, really good. And what I'll do as well is let me get what is it? OneNote. Let me get the whiteboard out as well, just for anybody that needs it. So all of the work that we've done today, you can access as well here. Yeah, so let me put this in the chat. So this is this here that I've just sent in the chat. If you go to A-level maths, and then if you go to mechanics 17th of June, this is all the work that we've done today. You'll be able to access it here. Yeah, you see, it should load. But yeah, this is all the work. So if you want to go over it again, you're more than welcome to. Yeah. So yeah, guys, hope you found that all beneficial. Let me just check the chat. Just see the chat. Okay. Okay. You're welcome. You're welcome. You're welcome, guys. It's been a pleasure. Sorry, I've taken up basically an hour and a half of your time. Please enjoy the rest of your day. And I'm sure I'm going to see a lot of you again tomorrow for stats. Yeah. It's stats tomorrow. Yeah. Stats is tomorrow at 12 to 1 again. Yeah. So we're going to do a couple of questions and yeah, hopefully should be good. Yeah. Stats is my favorite subject and my students know that. But yeah, cool. Guys, have a great, great Saturday and I'll see you guys soon. This will be uploaded today. So yeah, take care.